What's up, guys? Welcome back. Welcome to the dance stage. It's so lame. I am so lame. Update on Cal. Check this out. Have a look down here. That is our app. That's right. It's been a little bit delayed, the alpha, as I was telling you the other week. If you're new around here, I'm creating the first ever quantum-proof VPN, so you should go sign up in the description. But anyway, I was updating you guys. Yeah, a little bit delayed. The guy I'm creating it with, he has a baby due next month, and there's been some complications, so we're working around that, my friends. So it's coming, don't worry. And but fun little fact, his baby is due on the fun set of facts. Might actually make you believe in astrology. I shouldn't troll on this channel, otherwise people just believe in wacky things. Don't take that stuff seriously, please. But yeah, this baby is due on the 28th of August, right? And that is a curious date because that is also my dad's birthday. And if you've been watching for a while, you know I was raised by a single mom, don't have much to do with the dad. Anyway, his birthday is the 28th of August. So I've been in 2 serious relationships. We're doing a bit of a history about me now. And my first serious relationship, her birthday was the 28th of August as well, right? And then the second serious relationship, her birthday was the 14th of October. Guess what my mum's birthday is? The woman who raised me, 14th of October. It gets weirder. So that dad guy, he had a child with another woman when I was a young boy. So one of my brothers, I have a few brothers that I don't really know too well. But anyway, that woman's birthday was also the 14th of October. Just crazy. And now this guy is married, and I believe someone over there in that side as well has a birthday on the 14th of October. So yeah, that is a lot of coincidences, isn't it? Almost enough to make you believe in astrology. Don't do it. Don't do it. It is absolutely BS. Anyway, come on guys, let's get into some science. I'm so lame. Today we're checking out solar flares and mass ejections. Not those mass ejections. Coronal mass ejections. These things are really cool. I am a big fan of mass ejections. So, shall we get into it? Shall we? If it ever loads.
The sun. Smooth.
Oh dear.
And round and peaceful. Except when it suddenly vomits radiation and plasma in random directions. Solar flares and coronal mass ejections, or CMEs, can hit Earth and have serious consequences for humanity.
Oh yeah.
How exactly do they work? How bad could they be? And can we prepare for them?
It's interesting that he has a volcanic little animation there, because I know an interesting fact. These solar flares can actually be as powerful as like 10 million times volcanic eruptions. Or 1 billion nuclear bombs. That's right, you heard me right. 1 billion.
While the sun seems pretty solid, it's actually like a very hot ocean. So hot that it rips atoms into electrons and nuclei, all flowing around each other in a plasma. This plasma is pushed around and shaped by the sun's magnetic field, similar to how the sun's gravitational field reaches out to the planets and shapes their orbits. But magnetism is very different from gravity.
So that magnetic field of the sun, we don't know how it's created, where it comes from. We'll get into it, don't worry. I'm not going to talk too much of the stuff.
Magnetism is one part of a dual force, electromagnetism.
Ooh.
Electricity creates magnetic fields, and magnetic fields create electricity. On the sun, the plasma...
You want to understand that? You got to go study physics. It's a deep thing there. But just to give maybe a bit more intuitive understanding, if you move an electric charge around, you'll generate a magnetic field. If you move magnet around, you're going to generate an electric current if you do it in such a way. And that's what creates Earth's magnetic field. We've got the core of Earth is actually mostly metal, iron and nickel, and the Earth is spinning, right? And so this generates a magnetic field. However, the sun, on the other hand, we have no idea how this magnetic field is forming, and we're going to talk about it, don't you worry.
Made of electrically charged protons and electrons creates a magnetic field as they move, and this magnetic field then shapes the flow of particles. They're stuck in a dynamic feedback loop called a dynamo, which keeps the sun's magnetic field alive. This magnetic field stores enormous amounts of energy and leaks out over the solar system. It carries with it a constant trickle of solar plasma like a light rain known as the solar wind, creating a sort of space weather. But it isn't always calm and smooth. As the sun's plasma churns and flows around itself, its magnetic field gets all kinked and twisted. This creates magnetic knots that build up enormous amounts.
So see here, what's going on? You've got two sunspots. So you actually need two for one of these solar flares or coronal mass ejections to kind of form. Like if you just have one, it doesn't really work. And what these sunspots are, they're very intriguing things. They're actually a sign of like an increased magnetic field in that region. And so you probably know it's a region of decreased temperature. What decreases the temperature? Well, we know the magnetic field is decreasing this temperature. And so, yeah, maybe we come back to this point. But you need two for the magnetic field lines, one to basically be going positive and one to be going negative. And yeah, that's how they can twist and shit.
When the magnetic knots break, like a tangle of springs exploding outwards, the sun can vomit plasma and other awful things into the solar system.
Yeah, these things release like 1 billion tons of and they can travel at like several million kilometers per hour. If they're super powerful, they can reach the Earth in like the coronal mass ejections, that is, in like a day. Generally, I think it's 2 to 3 days. The solar flares. Now those things, they're very bright. Like I said, it's like an massive explosion on the sun with 1 billion nuclear weapons worth of energy. And those things obviously travel at the speed of light because it's just, you know, electromagnetic radiation. Whereas the coronal mass ejections is like highly charged. It's literally matter coming from the sun.
Like solar flares, a tidal wave of high-energy radiation.
Oh, here we go.
They race through the solar system at the speed of light, sweeping up protons in the solar wind, accelerating them into a high-speed solar proton storm. Then there are coronal mass ejections, which rip millions or billions of tons of plasma from the sun's atmosphere, catapulting it through the solar system at speeds of up to 9 million kilometers per hour. When these monsters hit us, nothing happens on Earth.
What happens is it hits that magnetic field he just sort of showed you, and they like funnel down the magnetic field lines. They kind of like oscillate. It kind of creates like a little hole in the magnetic field, and then yeah, it funnels down, or it gets stuck in the radiation belts and hits Earth's atmosphere over the poles. So yeah, the magnetic field of Earth is definitely protecting us. If you didn't know, like if we were to move, say, New York City to the moon, for instance, right, and one of these coronal mass ejections, you know, powerful one hit it, it could literally just destroy the city. That's how deadly these things are. But our atmosphere, Jesus, and magnetic field are really saving our butts.
While even smaller storms.
If you didn't know, that's what creates the auroras. It's this solar wind, essentially, you know, getting funneled down these magnetic field lines, and that's why you see them around the polar regions. That's what it is creating it. As to it's a little bit more complicated how, you know, the lights get displayed, but maybe we can come back to that.
Storms can damage satellites, affect radio communication, or be dangerous to astronauts. For people on the surface, space weather is harmless. Earth's atmosphere protects us from the worst.
Is it really harmless? There's some new studies coming out to show that there's actually an increased rate of... There's so much I wanted to talk about there, but there's an increased rate of heart attacks, cardiovascular deaths around high solar activity. I was reading this incredible study, I remember, and basically they looked at the deaths. They compared cardiovascular deaths to solar activity from the years, I think it was like 1985 to 2013. And they basically found that in regions of, in times of high solar activity, on average in the US, there was like 5,500 more deaths annually, which is really incredible. And so another thing they did was they looked at, they found when they did some tests on people's hearts in the previous 24 hours, if there was a high solar activity, they found there was reduced heart variability, I believe, and that's a sign of the heart being strained. I think I read, and so yeah, that's kind of crazy. Like when we think about risk factors for cardiovascular disease, obesity, diabetes, smoking, things like that, right? But we don't consider the environment. So maybe we should, because that's just looking at activity since 1985, and there hasn't really been any significant flares or super flares, as I'm sure we're going to talk about. So I wonder what these super flares are potentially doing for people's hearts. And you might be confused by this as well. If you didn't know, the heart has some stuff to do with electricity. It's pretty crazy. That is a very convoluted discussion, though. I think it's enough just to say that. And so when you have... Anyway, let's just continue.
First effects of a solar flare by absorbing the blast of X-rays high up in the atmosphere, well before it reaches the surface. The electrified plasma from a CME is deflected by the Earth's magnetic field, diverting the energy storm to the north and south poles, where energetic particles fall into the atmosphere, causing the atmosphere to glow and creating beautiful auroras.
A little bit more
As with any
complicated than
sort
that.
of weather, most of the time things are fine. Sometimes there are hurricanes though, or in the case of the sun, solar superstorms. And we know that they happen once or twice every century. If one were to happen
there's some interesting stuff coming out these days. You can actually see you know how trees, when they age, they have those rings? Well, what is it, carbon 14 or carbon 15 forms when these solar flares happen, and you can see it in these tree rings. And so we've actually found some notable events in like the last 10,000 years at least, you know, because trees age, right? And yeah, from memory, there was one like around 10,000 years ago. There was one, a big one, 775 years ago, and some other notable ones as well in there.
Today, we would first detect strong solar flares, a sort of flash before the much more dangerous thunder. The thunder is a CME, consisting of billions of tons of hot magnetic plasma that crosses the 150 million kilometers between the sun and Earth in less than a day. When it arrives, it causes a shock wave that violently compresses the Earth's magnetic field and transfers energy into the magnetosphere. But it can get worse. If the magnetic field of the CME is aligned to Earth's in just the right way, the two magnetic fields merge. As the magnetic cloud passes over Earth, it stretches the Earth's field into a long tail. Eventually, the energy stored in the tail becomes too much to contain. It snaps and explosively releases its energy towards Earth. A geomagnetic storm has begun.
Did you guys see that movie Geostorm? It's pretty inaccurate, but it was awesome.
A few hundred years ago, nobody would have cared. This storm gushing over the Earth is not relevant for machines made out of meat and bones. But it's very relevant for machines made out of metal and wire. Remember the dynamo? Magnetism creates electric currents. Earth in the 21st century is covered in millions of kilometers of wires transporting electricity and a complex grid of machines like transformers that make this transfer possible. A CME's energy can induce currents in our power grid that can either completely shut it down or, worse, destroy the transformer stations that keep our grid running.
Yeah, basically because wires, you know, the more electromagnetism flowing through it, it can basically burn them and ruin them. And so every device or anything that is susceptible to electromagnetic fields or electromagnetic waves will be stuffed during a massive solar flare, particularly these transformers, which are extremely expensive and extremely hard to replace. And I hope he talks about it.
This has happened already, like when the Quebec power grid failed after a strong solar storm in 1989. But in general, our engineers know how to deal with these storms, and so we usually don't even notice. The last time a solar hurricane washed over Earth was in 1859. The Carrington event, the largest geomagnetic storms ever observed on Earth. Massive auroras occurred as far south as the Caribbean. There were actually some reports you could read a newspaper at night during this event, and that you could see auroras even in the US. In places, they were so bright that people got up thinking the sun was rising. Luckily, we only had one sort of modern technology: telegraph systems. They failed all over the world, shocking their operators and chucking out sparks. Today, we have a tad more technology, and our luck may run out soon. Another bad solar storm is bound to happen eventually.
That wasn't even a bad one, guys. Super flares can be 100,000 times more powerful than the Carrington event. And then there's even things called mega flares, and they can be like 10 million times more powerful. But you don't need to worry about that with our sun. It's usually the younger stars, which are more temperamental, a bit like humans. And yeah, I'm just going to give you forewarning. We're going to talk about all the mysteries of the sun a little bit later in the video. And like, there's just so much going on with the sun that we don't understand, like this 11-year cycle. And that's, you know, very correlated with these solar flares and things like that. But we'll come back to it, and the Carrington event.
A storm as strong as the Carrington event missed Earth only by a small margin in 2012. Studies projected that it would have inflicted serious damage to electronic systems globally, costing up to $2.6 trillion to the US alone. The time to replace all the damaged systems was estimated at between 4 and 10 years. It's hard to...
I'm glad he's brought this up, yeah, because this is what I wanted to talk about. It would take a long time. It would take so long, and we'd have no internet, no GPS, no TV. Kids would have to go outside. They wouldn't know what to do with themselves, these young kids today. And I mean, maybe it could actually be good for civilization, to be honest. But yes, the damages would be severe. I think we should keep watching.
Say how bad it could have been. Experts disagreed. Some assumed there would just be temporary blackouts, but others worried it could be much worse.
Yeah, if
we
it
won't know
had
for sure until
come
a
like
big solar
9 days
hurricane hits
earlier,
us.
I believe
The
it would have hit
probability of
us.
such an event is estimated to be 12% per decade. That's about a 50-50 chance of at least one in the next 50 years. And there is more unsettling news. A 2019 paper found that even calm stars like our sun can create superflares every few thousand years. Eruptions orders of magnitude stronger than the strongest storms we have observed in the solar system. If such a storm hits us unprepared, the consequences could be catastrophic. It's hard to overstate how much we depend on electricity. It's not just the lights at home, it means no computers, no communication, no navigation. A sustained power outage might lead to a breakdown of the supply chain, water supply systems failing, and hospital generators running dry.
Satellites as well, they would take a long time to replace, possibly even decades.
Supermarkets not being refilled while food rots in the fields. The lack of power might make it extremely hard to reboot our broken power grid, taking years or decades to restart our starving civilization. Okay, time to panic. As much as daily newspapers might like for solar storms to send us back to the Stone Age, they probably won't. Fortunately, even though solar storms aren't preventable, virtually all of their nasty side effects are. Scientists observing the sun have a few hours up to a few days to see a CME coming. And the engineers working the systems that keep the world running are well aware of the risks posed by solar storms. Transformers and substations can be taken offline. Short preventative blackouts, or in other words, by unplugging stuff. Engineers can open up extra lines to dissipate the extra power. And with investment and upgrades cheap compared to those other natural disasters require, we could protect the world's electric grid against even the nastiest of storms. But we do need to prepare. While the risk is manageable, it is real. For while our sun bathes us in warm and pleasant light, one day it might send a monster our way that we better be ready for.
Yep, can definitely prepare for these things, but I wouldn't say we are currently prepared. So we're going to talk about the sun now and all the crazy stuff that I know about it, but let's have a read of the comments quickly because that's always fun. He's giving 2020 ideas and I don't like that. You wait till 2025, my friend. That's when solar maximum. So, you know, I mentioned briefly there's an 11-year cycle. It's quite mysterious. We know a little bit. But the next solar maximum is in 2025. So that's, and yeah, well, there's quite a few flares a day. There can be as many as like, 20 a day. So these things are constantly happening. Anyway, comments. 2020. Now, this seems like a marvelous idea. This guy's the only person who can tell us how fragile humanity is and still be optimistic. Solar hurricane narrowly missed Earth in 2012. Ancient Mayans. Oh, come on. We were so close. There's a real deadly laser. That's what's it called? The entire history of Earth, I guess. I did a video on that. You should go check it out. Knowing the average human, some people in countries would likely just refuse to unplug during a superstorm scenario and suffer the dire consequences. I can tell you, coming from Australia, that is true, because we have these things called bushfires, and they're, most summers. Sometimes they get really big and out of control, and they rip through people's houses and, that live in the bush. And we give them ample warning a lot of the time. We tell them to leave. And there comes a point where it's like, it's too late to leave. You have to stay. But a lot of people choose to stay and try and fight these monstrous fires, these huge walls of just flame with their hose. All right, shall we talk about the sun now? So I'll change this view over. So let's go into a little bit more detail about some of the things and mysteries of the sun that I can tell you guys about. And I wanted to say the CMEs, when they hit the Earth's magnetic field, they basically cause a bit of a drop in the Earth's magnetic field for a good 6 to 12 hours, even a couple of days. And this is what you call a geostorm. And the difference between solar flares as well and CMEs is basically that solar flares are X-rays and UV radiation, where CME is like literally a chunk of the sun that's just been launched at us. So you can see it's quite a bit different. And they both typically erupt from the equator of the sun. And in other types of stars, that can be quite a bit different. But we know they somewhat come from sunspots, right? But we don't really understand sunspots, or in general, how or where the Earth's magnetic field is, being generated from. And this relates to that 11-year cycle, but I was going to add in there that the solar orbiter has recently got some images from near the poles, which is brand new. We haven't seen it before, and we think these polar regions might be really important for the magnetic, where it could be generated, really. So I wanted to add that. But this 11-year cycle, so this is a very interesting and mysterious thing. So we're entering another peak. 2025 will be the next solar maximum. The peak of that 11-year cycle, and so it's associated with more solar flares, more CMEs, and at its peak there's something like 20 solar flares a day, which is quite a lot, right? So a really strange thing during this 11-year cycle is that the magnetic poles flip. So, the north becomes the south and the south becomes the north. We don't know how or why this is happening. It's just another one of the mysteries of this 11-year cycle. And another really strange thing is this 11-year cycle seemed to stop for like a good 70 years. We have no idea why. And it's kind of puzzled us for like the last 300 years. But recently we saw a similar thing happen in a neighboring star. So that's intriguing. And so who knows what's going on? Is the sun's magnetic field turning off? Are the dynamos stopping? Like, these are things we actually need to consider. Another really intriguing thing to think about is how the sun spins. Like, obviously this is going to be related to everything that we've already talked about, right? Because it's really strange. It's not like one solid thing. The equator, what is it, like 25 days for a rotation, whereas the poles, it's something like 30 to 32 days. So they're spinning at different rates, all around the sun. And then as you go into the sun, they're also spinning at different rates. So, you've got the outer layer spinning, and then as you go under that, it's actually spinning faster. And then if you go deeper, it actually slows down again. And then if you go deep enough, like I think it's 200 million kilometers in, it actually kind of spins like a solid surface, like the Earth. And we know that from sunquakes. We'll come back to what sunquakes are because they're really cool. But I was going to mention there's another mysterious thing with the outermost layer of the sun is actually like 1,000 times hotter than the surface, which is really odd. And we don't really know how energy gets deposited in that region, like why it doesn't just continue on into, space. So we don't understand that. And then maybe, you've heard about, we know what the sun's made of, but you might not understand that we don't actually know the chemical composition of the sun. Like, we know all of the stuff it's kind of made of, but the abundances of these things we actually don't know. So let's talk about sunquakes to finish off. They're really cool things. And we discovered them in like 96, and it took so long because the turbulence almost overwhelms the ripples. And like, on average, I think the sunquakes are like 40,000 times more energetic than the 1906 San Francisco earthquake. So these things are very powerful. And another mysterious difference is that the compression waves accelerate in the sun. like up to 250,000 miles per hour. They're just bizarre things, and then they disappear. All right, that'll do it for today's video, guys. I hope you enjoyed. Make sure you subscribe. Go check out CalVPN in the description. I'll catch you next time.